Welcome back to Physics with Miyoshi. I'm here with my trusty rope here, talking about a little bit about tension force, and I have this rope here to demonstrate a little bit about about tension. And notice as I pull this rope, it pulls back on me, and that's got to be true because of Newton's second law and third law. There's no acceleration. I'm not moving, nor is the object at the other end of my rope. And so there can't be an acceleration. So that means that the tension I'm pulling on this rope, this way, has to be equal to the tension going on along the other way, so that there is no acceleration in this particular direction along the rope. If I let go, and then there would be some acceleration, and we're not worried about the forces on the ground, on this friction that's holding, pushing back and all that, but and hopefully I don't fall down if I do let go, but this guy here is pulling me back with the same tension I'm pulling on it. So, and again, if I let go, we accelerate, and so does the rope. But I want to talk about tension forces just a little bit differently than just a rope. In most of the cases, when we study physics, usually we think of a rope, unlike this rope. This has some mass to it, but we tend to think of our ropes as massless. And when we do that, we find that not only is it true that the tension gets transmitted along a stationary rope that's stationary, that we always will have, there's not any loss of tension from one side to the other due to the mass. Also, if we have an object that we've connected a rope to, that the object will receive the same amount of force at the place where it's connected to the rope as you would exert on the end of the rope. And that would only be true as long as it's massless. In reality, the mass of the rope would matter some as well. We do the same thing with a pulley, assuming that the pulley is frictionless and massless. That way, and if the rope and the pulley have no mass and they are frictionless, then the tension on one side of the rope would be the same as the tension on the other side of the rope, just like you saw with my rope here. And we see that that tension, or that force of tension, does get transmitted if it's massless, because there is no mass. That means there is no force needed to accelerate or move the rope in any of these cases. And so that's how we think about tension force and about ropes in most of our physics thought experiments and in our calculations. So just a little bit of tension force and a little bit about ropes and massless ropes and tension, and just think about this silly demonstration with the rope and me holding on here. Remember, when you think about that, remember that the tension that the rope exerts on me is equal to the tension that I exert on it. And remember that as we go through our physics calculations, that we can assume that the ropes are massless, and so therefore transmit all the force all the time, all the way from that end to this end. Thanks for tuning in to Physics with Miyoshi, and hopefully you learned a little bit more about tension force, and tune in next time when we'll learn a little bit more about all this fun physics stuff. Thanks for tuning in. Bye-bye.